Welcome! Have you ever wished you had a GPS for your project? You know, something that shows you the best route and all the connections? Well, that's pretty much what we're exploring today with the network planning model. It's a tool that literally maps out every single step.
So, here's our game plan. We'll kick things off by defining what this model actually is. Then we'll look at the two main ways to build one, cover the absolute must-follow rules, and finally we'll walk through a complete example, sketch and all.
Okay, let's get right into it. What exactly are we talking about when we say network model? It's a term that gets thrown around a lot, so let's pin down what it really means.
To put it simply, think of it as a visual flowchart for your entire project. It's not just a list of tasks, it actually maps them out, showing every single activity and how they all connect to each other.
And here's the crucial part. This isn't some static to-do list. No, it's a dynamic map of all the dependencies. And on this map, time is strictly a one-way street. It always moves forward, from left to right, from the project's start to its finish. So, how do we actually draw one of these things? It's not just random scribbles. There are actually two main philosophies for how you represent the work. One is a bit old school, and one is what pretty much everyone uses today.
On the one hand, you've got the original method, activity on arrow, where the arrows themselves are the tasks. But the modern standard, and what we're going to focus on, is activity on node. Here, the boxes are the tasks, and the arrows just show the flow. Much more intuitive, right?
And you know, there's a really good reason why this method took over. It's also called a precedence network, and it's what you'll find in pretty much any project management software out there. Why? Because it's way more flexible, and it neatly dodges some of the confusing problems the older method could run into.
So, now that we know we're using the activity on node approach, how do we build one correctly? Because you can't just start throwing boxes and arrows on a page and hope for the best. There are a few essential rules you've got to follow to make sure it all makes logical sense.
Just think of these as the fundamental laws of physics for your project map. Every single project needs one, and only one, official start and one official end. The activities, those are the boxes, they take time. But the arrows connecting them, they're instant. They just show that this has to happen before that can begin. Now this is where it gets interesting. The logic in a network model is incredibly powerful, but it's also surprisingly easy to break. So let's look at two of the most common mistakes that can completely wreck your whole plan.
And here's the first big no-no, perfectly illustrated: the loop. Just follow the logic here for a second. You have to correct errors to test the program, but you only diagnose errors after you test it, which then sends you right back to correcting them. It's an impossible situation. A total paradox. A network must always move forward.
The second classic error is what we call a dangle. See how the task write user manual is just kind of floating out there? It's not connected to the project's finish line. This is a huge problem because it means the completion of this task has no clear link to the project's overall completion. Every single task has to eventually connect to that final end node.
All right, enough with the theory and the mistakes. Let's get to the fun part. In this final section, we're going to see how all these rules come together in a complete, neat network sketch. This is where it all clicks.
So let's take a look at a precedence network for an example project that does everything right.
And here it is. Now, I know, at first glance, it might just look like a bunch of boxes and arrows, but trust me, this diagram tells a complete and really clear story about this project's flow, its dependencies, and even its timeline. So first things first, let's just look at the overall structure. See how it's perfectly framed? There's one single unambiguous start on the far left and one single finish on the far right. That's rules 1 and 2, checked off perfectly. Now, each of these boxes, or nodes, that's a specific piece of work that needs to get done. And right inside each box, you can see the activity name and how long it's expected to take. For example, activity F, recruit staff, well, that's a big one. It's estimated to take a full 10 weeks. In the lines, the links, they are the logic that holds this entire plan together. They show us the required sequence. So for example, take a look at activity H, install and test. See those two arrows pointing into it from C and D? That means you absolutely cannot start installing and testing until both the hardware is installed and the data migration is totally complete. So the big takeaway here is that this isn't just a pretty diagram. It's a powerful strategic tool. It forces you to think critically about the sequence and the dependencies, which, let's be honest, is the absolute foundation of any realistic project plan. And that leaves us with one final thought to chew on. Seeing all these dependencies laid out visually like this, how might that change the way a manager allocates people and resources compared to just working off a simple checklist?